This is just a quick demo of a couple of oscillators that I have developed. Two of them are exotic LFOs, and one is a pitched oscillator which has a discontinuity which is corrected using blip. So to get to the first one, which is the pitched oscillator, the exotic waveform looks something like this. It is a increasing sawtooth followed by a gap in the middle with a circle, like an equation of a circle that is put in there, and followed by another sawtooth. And since it's a C1 continuity, because of the slope being equal at both periphery, it can be corrected using blip. So here's how it sounds without blip correction at 100 Hertz. Now I'm going to toggle the blip correction on and off and show you what it looks like on the oscilloscope. So here we go. As you can see, the blip correction removes a lot of aliasing that is present due to the discontinuities. Now I'm going to go forward and move to the LFOs, which I have used. So for the first LFO, I have defined 5 points along the axis of the LFO, which you can modify as to what kind of waveform you want. It can be flat, as in it just maintains the previous state. It can be linear increments, that means that it increases linearly. It can be linear decrement. It can be exponentially increment, and it can be exponentially decreed, or it could be zero. So I'm just going to show you how it looks like on the spectrum analyzer. So switch it on. Right now you don't hear any sound because it's flat and it's been initialized to 0. So if you see in the oscilloscope, there will be nothing. But as soon as I move it to a linear increment, right now the frequency is really low. So as I increase the frequency, you can see that since the wave has been broken down into 5 parts, only the first part has been made a linear increment, so only that has run. So if I make all of them linear increments, as you can see, if I make all of them linear increments, they all combine to make a sawtooth wave. Now I can make a lot of changes to them based on the kind of wave I want, or I could also change the starting point and the ending point of each point. So what that means is that right now each point has a fixed duration that it takes effect on. Right now, since there are 5 points, it will be at a interval of 0.2. So the first point will affect 0 to 0.2, then the next point will affect 0.2 to 0.4. So I can change that. I can change the first point 1 finish to even 1. That means that only the first point will affect the entire wave. Or I could change the changing start. So that means that different starting points would lead to different sound effects. So let me just give you a small demonstration of what could be done with this. You can get some pretty cool sounds out of this. The next LFO that I'm going to talk about is the second LFO that I have developed, which is an exotic waveform. I call it the sine shock because it's a mixture of a sine with a shock tooth. Let me just show you how that looks like. as you can see, it looks like a increasing exponential with a sine followed by a drop using a sawtooth. So that's the second exotic waveform, and I'm using a third LFO to modulate between these two. So let me show you how it sounds combined. Note that this is going to be used to trigger other pitched oscillators, so there might be a lot of aliasing and it might sound like crap. But the idea is that if you get a waveform that is changing states, we can use that to modulate different effects. That was my demo. Hope you like it. Thank you.